In this video, we're going to take a quick look at DeMorgans laws. This is just going to be an introduction. DeMorgans laws is a kind of Boolean algebra law that deals with splitting up a knot bar, like this bar right here, or like this bar right here. What happens when you split up a knot? So first, I just want you to consider what this first statement means. Let's say A stands for apples and B stands for bananas. This first statement would say, I do not like apples, right? This is a not here. I do not like apples and I do not like bananas. That's what this first statement says. I do not like apples and I do not like bananas. So I want you to consider for a moment which of these other three statements would be equivalent to this first statement. Is it this one? It is false that I like apples and bananas. Is it this one? It is false that I like apples or bananas. Or it is this one? I do not like apples or I do not like bananas. You might want to pause the video and give it some thought just for a moment. Have you thought about it? Well, as it turns out, this first statement is equivalent to the statement underneath it, right? If I said, I do not like apples and I do not like bananas, it must mean I do not like either one of them. Well, that's what this statement underneath says. It is false that I like apples or bananas. I don't like either one of them. The rule is pretty simple. The rule is if you split up a bar, like this line right here, if I chop that line in half, I must change the sign. So if you split a line, you change the sign. In other words, this plus became a multiplication. The or became an and. So these two statements are equivalent to each other. I know you might have thought that maybe this guy is equivalent to the one next to it. Well, the one next to it says, it is false that I like apples and bananas. Well, if it's false that I like apples and bananas, that may mean that I don't like apples or I don't like bananas. Oh, wait a minute. That statement, this guy right here, is equivalent to the one underneath it, to this guy. It's the same rule. If I split a line, I'm splitting this bar right here. If you split a line, you must change the sign. A little rhyme action going on for you there, right? I split the bar right here. The and becomes an or. The multiplication becomes a plus. That's it. That is DeMorgans law. If you split a line, you must change the sign. All right, underneath it, we're going to take a quick look at the proof, so hang in there. Here is the proof of DeMorgans law. So I'm going to fill in this truth table. Now, some of these columns I did already. Here's my A and B column. This is not A, of course. I just took A and knotted it. So a 0 became a 1 and a 1 became a 0. And here's my not B column. So let's complete the rest of the columns, shall we? So let's do A and B, right? I'm just looking at the A and B column. And of course, it's all zeros except where A and B are both ones. So the only place I get a 1 is when A is a 1 and B is a 1. If I complete A or B, well, that's of course a 1 if I have a 1 in either the A or B, right? So that's a 1, that's a 1, that's a 1, 1, 1, 1. Now let's do A and B knotted, right? I'm just looking at this column and I'm knotting it. Okay, so that would be 1, 1, 1, 0, right? That's just the opposite of this column. Zeros become ones, the 1 becomes a 0. Now let's do this column. This is A or B knotted. So I'm going to look at this column and knot it. So the 0 becomes a 1 and the 1s become zeros. Okay, two more columns. Let's do not A or not B. Well, I'm going to look at this guy, not A or not B. And if either one of them is a 1, I get a 1. So I will get a 1, a 1, a 1, and a 0. 1, 1, 1, 0. And finally, this last one is not A ANDed with not B. That is these two guys ANDed together. So I'm going to look for a case where they're both ones, right? I'm ANDing these together. So that's going to be a 1, and the rest are going to be zeros. 1, 0, 0, 0. Now remember, DeMorgans law says if you split a bar, like this guy right here, if you split a bar, the sign must change, right? Split the line, change the sign. So this column should be equivalent to, I'm going to connect it to this column. And if you look, they are 1, 1, 1, 0, 1, 1, 1, 0. And likewise, this column right here should be equivalent, right? If I split this bar, should be equivalent to the very last column. Split the line, change the sign, and in fact, these columns are equivalent. 1, 0, 0, 0, 1, 0, 0, 0. So that is proof. That's a great thing about Boolean algebra. You can prove it just using a little truth table. So split the line, change the sign, and you should be good to go.